Well, and about the money, the monetary aspect, like I remember being at a customer's office and he looked at what was it, a 30-page report that we did. And he looked at this and he's like, look, every single thing on here is a stage and every stage is worth $500,000 to us. And there was probably 20 to 30 stages that we had saved in this report. And he's just like, there's a stage, there's a stage, there's a stage. Like the business sense or the financial cost of not knowing is huge. Welcome back to Nerding Out with Cold Bore Technology. Today we're diving into IntelliSonic. We've talked about this technology before, but this time we're taking a different approach by looking at it through the lens of AI and machine learning. There's been a lot of conversation lately around intelligent operations, real-time decision-making, and how AI is changing the energy industry. So we thought this would be the perfect opportunity to explore where IntelliSonic fits into that evolution. We'll break down what IntelliSonic actually does, why it was built, the story behind Perceptor, and how machine learning is helping transform acoustic data into meaningful operational insights. We'll also talk about where we see the future of acoustic monitoring heading and what that could mean for completions over the next several years. I'm Craig Bergman. This is
Hector Nunez.
And
Nicolai Pecorari.
And welcome to Nerding Out with Cold Bore. So let's talk about a really interesting news clip that I found. Of course, there's a lot of I'd like to say topics or a lot of talk about data center creation and what's going on in different industries, power consumption, and all the green aspects of data center. Never mind the constant push of new models. One thing that I found really interesting is actually what AI can be used for. For me, this idea of investing in or seeing the stocks rise and fall with data center creation or projected application is cool, but what does it do today? This news article titled, "Can AI Salvage the Surveys Abandoned by Humans?" I found particularly interesting. So what happens is people, maybe you get some coins for an application or something like that. You click on a thing for an online survey, you start filling it out, you get about 15 questions in, and all of a sudden the question is, how much is my time worth? Well, it's worth more than filling out the rest of the survey, so people abandon these. What this is there's a complete the incompletes application, and they took AI and they applied the previous answers that people have done, and they asked AI to predict the remainder of the answers. And previously, looking at it, you could see they had a very low baseline, like 25 odd percent on what people would guess or how they would complete this. But using AI, accuracy improved from 55% to 90% of the match rate. So I think this is particularly appropriate and super neat because we're talking about using AI ML to predict and understand what's happening downhole, to take some of this indeterminacy in a place. Like we can't put a flashlight, we can't see it. But we do have sensors and we're trying to guess what's happening around our sensors. Well, this is kind of the same thing, but in a real world application. You guys are supposed to make up stuff to talk about.
I understand the AI application in that survey, completing the survey, completing what the humans are saying. But I think it's a very subjective matter there because, people think different. They have, different thoughts, different beliefs. However, the applicability in the completions business that we work in, I think it's a lot more, it's greater, it's more beneficial because it's an exact science almost. When we got into the business, into the oil and gas business, into directional drilling, and then into the completion, it's because we're dealing with decimal points. And we understand that if you have a mathematical mind, a little bit of a mathematical mind, then you get to understand. So to me, I think the AI predictability is a lot better in this domain that we're working in.
I got you. So instead of looking at like 20% to 50, 60% accuracy, you're predicting closer to the 90% accuracy.
Absolutely. Although geology is an fairly abstract science, it's a lot of interpretation there. However, completion isn't. Completion deals with pressures and volumes and the response of the rock. So
the different formations and the basins.
Exactly.
The programs, how do they complete the wells, right? Like
Exactly. So you can use historical data, you can use real-time data. The AI applicabilities is far greater to me than in a human application where you got to talk about a survey about your finances or about your beliefs.
Yeah, about your feelings. So the AI can predict your feelings. Well, actually, we know what happened downhole. We just put a camera down there to confirm, and then we can go back and fix the AI bias.
That's right. And the same for the IntelliSonic application. Since we're talking about the IntelliSonic application, as I mentioned, the business we're in deals with pressures and volumes. The IntelliSonic gives an extra sensory perception. It gives you an audible information, which again, you need to learn it. You need to be able to interpret it, but you need to understand what the sounds mean. And that was the basis of how we started it and why we started it. Just because there is not enough data to make a decision in real time. The instruments used in the data van or on a daily basis on a completion site are, enough sophisticated to give you okay data. IntelliSonic has it's a order of magnitude level of information, very, very sophisticated instruments, high fidelity, that by interpretation now all of a sudden you have this extra sensory perception of understanding what is happening downhole.
Wow, that's right. I remember a decade ago when we were talking to customers about IntelliSonic, as it was a new technology at that time. And the thing that kept coming up was like pressure is a response to what we're doing on surface. Like we increase the flow rate, something happens downhole, the pressure increases. So they infer what happened. But in the case of Sonic, we're actually hearing the live events. We're not seeing a reaction to an event. So it's not a second order or a secondary consequence. It is actually listening to what's happening.
So Hector can talk more about the Perceptor and the IntelliSonic because he's the one who built the Perceptor software with the idea that there is a niche in the market that we can apply this technology to understand what is happening downhole.
So yeah, the idea came from us going to the field and having these trials of the sensors, right? Like of course there was a lot of hardware development and ideation discovery before we actually got to build any software, and we can talk about that after. But the idea was to prove that we will listen to something. So we started by gathering the data, the high frequency sound data, right, in that trial job. Once we had that, it was a matter of putting it into a dashboard, a software that we can show to the clients, right? Like that they can actually see and understand what we're saying that we're hearing, right? So building these graphs and being able to identify them as an event, that was the main goal of the of Perceptor software, right? You're going to ask why Perceptor?
Yeah, how did you come up with the name of Perceptor?
So smooth.
So exactly, I can't remember, but probably just like trying to find a way to name these. I was looking over Transformers. I don't know why Transformers, but that was in my brain at that time, and found the name of Perceptor, which is an Autobot, right? Named Perceptor. That he transforms into a microscope, and he's his superpowers, I guess, is the intelligence. He's very intelligent and very perceptive of details, right? The minute details and being able to infer things where others can't, right? So I thought it was an excellent name for it.
Something has been bothering me for a long time. Why didn't we go with the tape deck transformer? I think his name's Soundwave.
The reason we didn't do that, if I may again, my infer Perceptor is the smartest of the transformers, and we wanted to have the smartest software at that time. And dare to say, it still exists today, and it still works very, very well. So since we built it 10 years ago, we utilized it in the field with great success. And the initial application was to listen and confirm ball drops and ball seating in the right spot and port opening. And although Perceptor hasn't changed per se, but the application has changed gradually. And now the IntelliSonic is being applied to smart darts and smart balls and smart collets. And we even listen to adjacent events, plug and perf, guns going,
Yeah.
motor or downhole motor, cleaning plugs, so on and so forth. So the applications are endless. We're looking right now into geothermal applications, cleaning the wellbore. During the geothermal production, there is a lot of calcium and a lot of deposits inside the pipe that they need to be cleaned with the mill, with the air hammer. And there is an application for the IntelliSonic to confirm the functionality of the tools downhole. So the evolution is there, the evolution exists. Even further to that, we've seen it as of late. We've been concentrating solely on downhole events, confirming downhole events. But the industry is shifting right now to understand the surface events as well, which is cool, really, really neat. We're going to do fast operations, and everything has to work like clockwork.
Well, and I guess what would have prevented people from just knowing what's happening on surface 10 years ago is you just throw another person at it. Is the pipe jacking? No problem. We'll bring a person in. His job will be to watch that pipe, and if it jacks, he'll let us know and we'll go and handle it. But now it's how many people can we take off of location? How fast can we do it? And we don't have to ask the question. We need the pipe jack monitor 24 hours a day.
That's exactly right.
Hector, what exactly does IntelliSonic do?
IntelliSonic came about the pain point of a new tool in the industry, the ball dropping systems. There was a problem there that the engineers, they were flying solo in terms of not knowing when those systems operated properly or not, right? These systems came about from wireline being a little bit too slow when you have to travel down and travel up. They created these ball drop systems to speed up the operations of fracking, right? Where we come in, IntelliSonic, we realized that we could close the gap there and provide more visibility to these engineers that were flying solo in terms of giving them the extra data that they need to be able to infer or to prove that the system, the third-party system, is actually working, right?
Well, and I remember when, like, before we did IntelliSonic for cold bore technology, when we were working on downhole telemetry, we had a couple of fantastic engineers. We called them scientists at the time, Barry and Larry, and their comment was, we can build this telemetry, but everybody we approach at a trade show, their question is, how many hundreds of thousands of hours do you have this tool running for to show us its success? And so then you take a ball drop person and you say, hey, we've got this ball, and it'll replace your big wireline unit and save you all this time. I could see, like, how do you prove that it's actually doing what you're selling me? Enter this trio as well as a company supporting us and Perceptor with the ability to, what does Perceptor do?
Yeah, I think that happened. To prove it, it wasn't hundreds of hours. It was the consistent lack of a good event, right? That we were actually detecting and saying, like, hey, we didn't hear this as the previous known profile of sounds and pressures, right? There might be something going on here that is not right. And sure enough, after quite a few of those episodes, which there are not that many, but they were able to confirm that there was problems downhole during those stages. So,
and the ability to have that information in real time is invaluable, because if this is a cheap operation, probably nobody would care. But it's a very expensive operation, tens of thousands of dollars per hour potentially, and you stop to try to understand what took place. Try to infer. Again, you only have pressure and volume. What took place? And there's many different scenarios. You add an extra perception, you add just the sound. Now you can make really informed decisions a lot faster in real time.
Well, and about the monetary aspect, like I remember being at a customer's office and he looked at a 30-page report that we did. And he looked at this and he's like, look, every single thing on here is a stage, and every stage is worth $500,000 to us. And there was probably 20 to 30 stages that we had saved in this report. And he's just like, there's a stage, there's a stage, there's a stage. Like the business sense or the financial cost of not knowing is huge. And if we didn't have sensors on site, what would they do? They just keep pumping and hope for the best.
Just move to the next stage.
That's right.
There is many instances that the customer loses a stage or two or three because we don't know what happened. We don't want to stop and troubleshoot. It takes too much time. The economic dictates let's move, or the office in town, they said let's move on. So it's great to have the information with you available at your fingertips.
Just 1 second.
Sorry.
Are you working with Claude?
Out of time.
Oh, Hector's time is ended.
Where should we leave off? Like, I don't mind talking.
First of all, I like how Hector has transformed.
The transformer?
The transformer.
I'm the new Perceptor.
You're the new Perceptor.
There's a new transformer. We didn't know about it.
Due to unfortunate circumstances, we've lost our third host. So now please introduce a person from behind the scenes.
Yes.
Milena.
Yes. Hello. Yes, I am the digital and marketing strategist here at Colbor. I just said, well, we missed one. We had to let one go. I'll jump in. I also created IntelliSonic 15 years ago. No, I've been here for 3 years. But every time I hear about IntelliSonic, I get more and more intrigued because I feel like I didn't know you guys started with it. That was the baby of Colbor, and then it slowly grew. And now we're back to focusing on it and revamping it and reintroducing it shortly. So
we even had our CTO make IntelliSonic great again hats. That was like last year or the year before that, and it didn't quite catch on, but now we're gonna do it for sure this time.
Make IntelliSonic great again.
Yeah.
What? Okay, we can do that.
But it was great once.
It was great
we
once.
Started it. So when we started it 10 years ago, that was the most amazing thing because, like you said, it was the three of us, Craig, Hector, myself, working in the shop. We do the hardware, the software, the field. We rotate. We do things. We come up with ideas, feedback. Oh, this works. This doesn't work.
Yeah.
The biggest breakthrough, of course, came in the field, actually listening to events. Hector and I were on the first job in February of 2016 at 2 o'clock in the morning, listening to a ball drop, and we heard it at 7,200 meters measured depth, and we looked at each other and high-fived. We got something.
What was the measurement? What was the length down?
7,200 meters measured depth.
Was that what you were aiming? Like, what was the threshold that you were first aiming for that you said, okay, this is where we want, like, this is the threshold of where this can happen, but then did it slowly become, deeper and deeper that you thought this can work?
Somewhat, yeah. The wells, of course, they become deeper in measured depth through the years. But to listen to an event at that time, 10 years ago, at over 21,000 feet, 7,200 meters of measured depth, it was an accomplishment then.
Yeah.
We knew that if we can do it and it was successful. It was loud. It had good quality of sound. And we knew if we have it here, this is just the beginning with this just very unsophisticated equipment that we had at that time. Of course, we can make it a lot better. Of course, we can improve on it. Of course, we can put filters and we can put better hardware, so on and so forth, which we promptly did through all these trials in the field, and created the Perceptor and the IntelliSonic that exists today. So a lot of trial and error in the field, but that is the major breakthrough that happened.
Yeah. And if every time, if you get a new, when we get a new customer, when we start working with someone new, what's the aha moment of their, like, you pitch it to them, they say, okay, that sounds great. That sounds like very useful to us. But is there like a moment that you remember, or like one of our tech guys or field tech can remember when it works and they go, oh, wow, I didn't know this was even possible before.
I love this. So early on before Perceptor was a name that we used, we just had our data acquisition thing that we were listening. And I was sent to on a trip down to the States to showcase our downhole acoustic telemetry. And also we have this thing that we'd like to listen to, some plug and perf operations to see what we can do. And hearing the operation in the field was cool. Don't get me wrong. But afterwards, I was at a boardroom for their company. Some of their technology officers were there. Their engineering team was there. And during the meeting, I had the rib and Perceptor running, and just a sensor sitting on a table. And one of their engineers is just sitting there, just tapping on the table and watching the signal on the screen, and then tapping on the wall and watching the signal on the screen. And it was probably an hour where he's just tapping different things. And then I got to play for them, this is what your plug and perf sounds like. And they're like, that's exactly it. Which is so neat, because we have our sensors that are not necessarily made for this application. And we have the downhole signal, and we're receiving it, digitizing it, reconstructing it into audio, and then replaying it. And they're like, that's exactly what it sounds like. And that's happened a couple of times, like with the ball drop. One time on a job on the first application, the engineers who designed the system, they heard it and like, that's it. It sounds like a shotgun sound. And we could clearly hear that from a mile downhole. Like that's those little moments of, wow, like I never thought I would be able to hear this happening is kind of those aha moments.
There's so many times that Craig and I, we sit in the data van, we go to new clients because, well, we heard you have a tool that you can listen to. We heard that you guys are the well whisperers. Sure.
Well whisperers. I like that.
Well whisperers.
That's our new tagline.
We sit in the data van and we turn the speaker up, and all of a sudden this, wow. Is that the sound from the ball hitting the seat?
Yeah.
And
That's
the
right.
sleeve opening?
Yeah.
Wow.
Yeah, guys, don't talk on the radio. Guys, everyone, shh, cold bar, turn that up. And it happens. Yay. Wow. And then we go and continue the operation. Like, it's so theatrical when it happens in real life.
Well, that's what I can imagine. Like, it's just this idea of I couldn't, it's almost like, this is maybe not a good example, but when, someone who's deaf gets, help with their ear, what are they called? Ear
things?
Ear things. And then they turn it on and it's like this light of, wow, I didn't even know this was
the videos of that I saw were not complimentary. But when a person with like some type of color blindness gets the fancy color glasses and they can all of a sudden see again, that's a fantastic video.
But I think that's like the crux of what, at least, marketing sometimes we want to tell people is, especially customers or potential customers or anyone that doesn't know about us, is the difference that SmartPad or IntelliSonic makes when you apply it to operations. And kind of, being in the dark before and having this whole new set of eyes on your operations. That's what we try and really portray online is a new awakening to a way of running your operations. Would you agree that's something that IntelliSonic obviously does?
Absolutely.
Yeah.
Absolutely it does. Having the extrasensory perception there, yes, it is critical. Also, it's worth mentioning that the evolution of the market. People started getting into smart darts, smart balls, smart collets, and they needed a form of validating the technology. So we were there to work with their partners right now, and or customers to become business partners, and we're able to be working step by step with them to make the technology validated for their customers.
That's right. Give them just the sense of surety that they're not pumping into the previous stage, or they didn't trigger something ahead of schedule. Like it's exactly what they're expecting to happen downhole.
Because the IntelliSonic produces a very large amount of data in real time. And right now we have eyes of operators, data technicians, looking, interpreting that data. We think this is a prime platform to be where the ML can be applied to. The events happen; they happen in sequence, and we think ML can easily learn the sequence of the events and understand it and apply it. So less human intervention will be used in the future.
Oh, that's fantastic. I remember when we were trying to do depth estimation like 10 years ago, and the Starlink didn't exist, high-speed field internet wasn't a thing, the ability to local compute or edge compute things just didn't happen 10 years ago, ironically enough. So we would have to take our data file and work on getting it to an analyst to actually run the math. Do you see that happening in real time on site?
Absolutely. We're working on the project right now, which will be out shortly, where the algorithm, and it's because of the things that you mentioned, Craig. We do have the ability now, a lot more than 10 years ago, to transmit the data in real time. We have computing power like no other. We are able to apply this algorithm, get the data in our hands on site, apply the algorithm, and calculate the depth of the event, hopefully in real time, like really close to when it happened. So the customer needs this. And, something happened downhole, but where did it happen?
Yeah, the first question is what happened? Oh, okay, well, that's cool. An event happened. Now where? Like, what do I do? Is really what the customer wants to know.
Exactly.
Nicolai, what's the biggest misconception about IntelliSonic?
That is a good one, Craig. Most people think it costs a lot of money, and there's just an okay technology that they don't need. But once they get it on site, they realize it is sometimes a cheap form of insurance. And having extra information is always better, and not that expensive, but very, very valuable.
That's fantastic. One of the things I was thinking of is, back in the day, they would start fracking a well, they'd encounter a problem, and then they'd call us out to tell us what the problem was. But because we weren't on site recording good stages and then recording the bad stage, all of a sudden our ability to show up and say, here's your problem, like an insurance adjuster. No, we actually, what I would say the biggest misconception in my heart is that we can show up and answer questions about what happened in the past without being there to record it. So we kind of need to have that continuous log of cost-effective data capture.
I agree.
Excellent. Milena, every completions engineer should know
About us.
I love it.
About us. Come on.
That's fantastic.
That's my job. Let me ask one. How about, should I ask, AI in completions will never replace what? Is that a too hard?
Pass.
Okay,
Next
pass.
question. No, AI in completions will never replace all people.
Yeah.
And this is something really, really important. Many years, well, a couple of years ago anyways, a customer called me up because our sales had been selling his sales team on what we're doing. And the customer, the operations superintendent, called me up and said, Craig, are you guys automating? And he named a couple of things that I'm not going to bring up. And my answer was, there'll always be a person required to do this job. Now, in the case of, let's say, automated valve opening and closing, or some type of communication between systems, always having that one person to hit yes, go is so critical because of the amount of money involved, or to do some of the interpretation. Like we can't go strictly 100% AI. We can get close to that line, but we can't replace everybody.
Yeah, because there's so much emphasis on manless operations. You still have to keep the integrity of the operations at heart with,
That's
people
right.
that are actually running it. So do you think there's too much of an emphasis on manless operations, or?
I think COVID actually really played a part in this. So too much emphasis, I don't know, but the idea of 100 sweaty people, because it's hot where we're doing a lot of our fracking, 100 sweaty people in a tight and closed space. Like there's a lot of brain power in that space. It's very limited, the scope of what they're looking at, the responsiveness. Like they're trying to take everybody and put them remotely or put them locally. As soon as COVID hit, and we're like, wait a minute, there's a contagion risk. So you have your very expensive engineer and the guy who's operating the pumps, very different pay scales. Maybe we should put the engineer outside of that environment. And that kind of started the strong push to actually maybe he can be at home. And maybe while he's at home, he can, instead of just on one pad, he can be watching 2 or 3 or 4 pads. Like this type of decentralization of brain power, or decentralization of operations resource from 100 miles outside of the city to in a comfortable area, I think is a fantastic push. And then supplementing that with AI and the capability of enhancing, like giving a carpenter a drill instead of a screwdriver, I think is a fantastic thing that the industry's been working on.
And in the same line of thinking, we got to think that technology has evolved greatly from 10 years ago. So you don't need as many people to operate valves, to operate equipment, because some technologies advanced to a point where there's hydraulics that can be operate the valves remotely, and some equipment remotely. So you don't need somebody to go into the hot zone. Of course, there's a safety aspect to it as well. Having 100 people on site comes with a risk, as opposed to have 20 people. So all this technology can only help improve safety record and reduce the number of people as well. At the end of the day, the technology can be operated remotely, like Craig mentioned. And because you're dealing with large volume of information, then you will need AI, you need ML to keep the sequence going, to keep the flow going, and don't have any gaps.
Mm-hmm. Interesting.
That's fantastic.
Yes, we'll have one more question here. What is something every completions engineer should know?
Oh, for me, is a very easy one. Every completion engineer out there should know that the more data they have available, the more valuable their job becomes, because they can make real-time decisions. They can make quick decisions, not necessarily real, but very fast decisions. So when you think about the speed, when you think about the money involved, so on and so forth, the number of people, we discussed about all those aspects, but having the data available to you, having ML, having a sort of AI aiding you into making these decisions, absolute king. IntelliSonic, SmartPad, those are the tools that everyone needs. They need to have this on a daily basis in order to make those fast decisions.
There was a quote from the chief technology officer from SLB that said, the winners in AI will be companies with the best data, the deepest domain expertise, and the ability to scale. And I think that's where we kind of play the biggest role, is we have the best, most robust data that we can provide to customers. So I completely agree.
Excellent. That was fantastic. Well, thank you very much, everybody, for watching. Please don't forget to like and subscribe. Put a comment below. We'd love to have ideas or other guests that we can bring on, so don't be shy reaching out to our marketing team. On behalf of that, you are?
Milena Moran.
And?
Nicolai Pecorari.
And Craig Bergman. Thanks for watching.
Nerds, data in hand. We rock the bytes and we'll take a stand. Calculators flashing like a disco ball. Cold board tech, hey, we answer the call.